Hey guys, welcome to another theory of computation tutorial. Today we'll look at another example of Moore machine. So let's get started. So we have to construct a Moore machine to generate ones complement of a given binary number. All right. So it's very easy actually. So now what is ones complement? So let's say you have got a binary number 1010. Okay. Now ones complement of that is you just invert the number. So if it is 1, you make it 0. If it is 0, you make it 1. So it is going to be 0, 1, 0, 1. Okay, or let's say 1 0 1 1 0. So you just ones complement is going to be 0 1 0 0 1. Okay, so this is how we get ones complement. Now how do you construct a Moore machine for that? So let's say we are in a starting state A. Okay, we are in starting state A and the first output for starting state A is, let's say, 0. Okay, now remember in Moore machine the output is dependent on the state, not the input. Okay, so if you are in state A and you get an input 0, okay, you get input 0, you go to state B. Okay, now we have to make sure that if you are getting input 0, it should reach a state B where the output should be 1. That is inverse of that, correct? So the output is going to be 1 over here. Okay, and if in the beginning from starting state A you get input 1, you go to state C. Okay, and here the output should be 0. Why? Because since we are giving the input 0, we have to bring it to a state where the output is going to be 0. Fine. All right. So this is the basic starting state. So if you get 0, you get the output as 1 in state B. Okay. Now what happens in state B? So if you are in state B, okay, and you get an input of 1, where do you go? You go to a state where the output is supposed to be 0. So from here you go to state C when the input is 1. Okay, and if you get 0, where do you go? So if you get 0, it should reach a state where the output is 1. So if you get 0, you should go to state B itself, because over here the output is 1. Fine. Now what about state C? So if you are in state C, you get input 0. Where do you go? You are already in state C, you get input 0, you should go to a state where the output is going to be 1. So you go to state B when you get an input 0. Okay, and if you get input 1, you should go to a state where the output is 0. So in state C output is 0, correct? So you go to state C itself. Okay, for input 1. Okay, so this is how we construct a Moore machine that generates ones complement of a given binary number. Now let's try passing some strings. So let's say we'll pass string 1100. Okay, so let's say you are in starting state A over here, correct? You are in starting state A, the output for the beginning state is 0. You can just neglect this first 0. Okay, now over here you get input 1, you go to state C, correct? State C output is 0, correct? Okay, now in state C you get input 1, you go to state C itself and you have the output 0. Okay, now over here in state C again you get input 0, you go to state B. Okay, and in state B you get the output as 1. Okay, and in state B you get input 0, you go to state B itself again and the output is 1. So the inverse of 1100 is 0011. Okay, you have to just neglect the first 0 over here. Okay, let's try passing some other string. Let's say 0100. So let's say you're in state A, starting state A, and the first output is going to be 0, just neglect it. Okay, and you get an input 0, you go to state B. Okay, now in state B the output is going to be 1. Then you get 1, you go to state C. Here the output is 0. Okay, in state C you get input 0, you go to state B and the output is 1, correct? 1. And in state B you get input 0, you go to state B itself and the output is 1. Okay, so the inverse of 0100 is 1011. Okay, so this is how we construct a Moore machine that generates ones complement of a given binary number. So I hope you got this concept. If you have any queries, feel free to ask me in the comment section below. Thank you very much.